for joining me today. I know that they're doing the Vault roadmap in the other room, so I really appreciate you guys all coming down to hear about another Vault setup we have going. Today I'm going to talk about fast secrets and a little bit about why their secrets need to match your infrastructure and how do you start leveraging that as well through that zero trust ideation that Armin was just talking about. My name is Sarah. I'm a field CTO here with HashiCorp. Usually I'm based on the other side of the pond in Amsterdam, but I'm in sunny LA, which I'm absolutely thrilled about because it's raining back home, as usual. I actually began my journey with HashiCorp products as a customer in the financial services industry. And before that, I was a software developer before I made the pivot into the security space. And I really have a passion and believe truly that security is an enabler, and it shouldn't be a showstopper for everyone. So at this point, we have pretty well established that a secret is a piece of information that we use to ensure that a user is authenticated in some way, shape, or form. And we want to make sure that this secret has the proper amount of privileges so that these workloads can do what they need to do. What we don't talk about quite as often is that there are really two kinds of events that we can look at secrets management within this life cycle. We have cornerstone events, and these are things that don't happen very often. Things like secrets acquisition, putting in place authentication mechanisms, bootstrapping your authorization permissions, secret revocation in the case of break glass, for example. But then we also have these continual events that are things like rotation and audit and logging to ensure that we have constant observability when we need it. But this isn't any different to what secrets management has been since the dawn of time when we started connecting workloads and saying, okay, maybe these things should have some accountability and be able to authenticate with a username and password. So what's changed? Well, we're kind of in this hybrid world, if we look at it that way. Everything's a little bit in limbo. On one side, we have these systems of engagement, which are applications that have an enormous amount of user engagement, and they have these spiky traffic. So we may see that they have 100,000 users at noon, but then that dies off around midnight, and we only have 10 users. On the flip side, we have these older systems of record. And these systems of record are things like our core databases, mainframe. They aren't as dynamic in nature, but now these two things are colliding. And we have to be able to reconcile the connection that occurs between these systems of engagement and these systems of record. Now, these systems of engagement, they're typically things we find on the cloud. They need to be deployed very quickly, and we need to be able to iterate over those as well. But because we need these systems of engagement to be built faster, more immutably, on lightweight infrastructure that we can react to in terms of cost implications, we've also started turning to things like containerization and to serverless. And the result is that we've ended up with an even more dynamic and even more ephemeral infrastructure. But concretely, what does that mean and what are these implications? Well, it means that now everything is connected, whether that's directly or indirectly. An attacker might be able to get a foothold into Slack, for example, and then pivot to own individual nodes, or even a cloud console. And as this infrastructure becomes increasingly dynamic and ephemeral, we also want it to become more immutable. Now, the analogy here that maybe you've heard Armin talk about before is that if we want to change the color of the kitchen, we're no longer going to repaint the kitchen. We're just going to bulldoze the entire house and rebuild the house with a new color kitchen. But in order to do that, we need to make sure that we have this fast iteration. And if we turn to Bain and McKinsey, what they're saying is there's a direct correlation between the speed of iteration and the performance of a team. So essentially, the higher and the quicker the iteration, the higher performing the team. But it also means that we're creating more microservices and containers and serverless because it's easier to be quicker, to be more immutable with smaller services than it is to be with these giant monoliths. But we still have these systems of record, and those systems of record are incredibly difficult to migrate. So the result is, again, this collision of the two. The problem there being that it gives us more opportunities for misconfiguration and lateral movement between both on-prem and in the cloud infrastructure. Now I have a confession to make to all of you. In my development career, I have never once in my life felt it necessary to change a secret or a certificate before it was absolutely necessary. I'm not known for my copy and pasting skills, and I don't want to be responsible for a system-wide outage due to my typing inadequacies. And I'm going to go out on a limb here and wager to guess that everyone in this room probably has a similar reflex. Now, the fact is, because an SSL certificate has been reduced to a 1-year lifetime, it means that this process has to happen a little bit more frequently. But those CA certificates that we use to ensure trust and identity across all of these various machines, they still have an indefinite lifespan. And if we look at Forrester actually says that 57% of companies have had some sort of secrets-related security incident within the past 2 years. If I look at the IDSA, they say that number is as high as 79%. And if you look at the amount of teams that have a standardized secrets management approach, which is 5%, the reasoning behind that becomes clearer, at least to me. But if we look on the flip side of this, and we start looking into containerization and what happens with containerization, this dynamic ephemeral workflow, we'll see that according to SysTig, 93% of containers live for 1 week or less. 44% of containers live for 5 minutes or less. If we look at the general ecosystem for containerization and the growth over the past several years, we'll see that 50% of companies have adopted Kubernetes. And that doesn't include other flavors of containerization. It's strictly Kubernetes. But when you think about one of your major security concerns and controls for Kubernetes are service accounts and RBAC, which are all identity-based, the fact that 60% of companies cannot track machine identities becomes a bit concerning. So my question to you, I'm not going to ride a kiddie car down the Autobahn without an international driver's license. So why am I using non-identity-based secrets to authenticate and authorize non-original entities on dynamic infrastructure? So what if I told you that the most common initial attack vector were compromised credentials? 1 in 5 breaches have an estimated initial attack vector of compromised credentials. And each of those attacks is estimated to cost about $4.37 million. So I'm going to ask you again. Why are we keeping long-lived credentials on ephemeral infrastructure? If we break this down, we essentially have a container security's hierarchy of needs. If you look at the foundational controls, one of those is secrets management. Now, in my experience, there's a lot of concern surrounding network segmentation, vulnerability management, and all of those things are extremely important. They're all part of that risk-based control. But if I'm not fulfilling those foundational controls, what I do above that becomes less relevant. Maybe that's because we feel like secrets management and secrets in general on these containerized workloads should come out of the box. But the reality is these are base 64 encoded strings holding incredibly sensitive information. Now, I, as an attacker, if I get a hold of that base 64 encoded string, all I have to do is run a simple script to essentially have that in plain text. One of the things we talk about here is that if I'm an attacker and I've gained access to your network, the first place I'm going to go is to your VCS. And I'm going to check for any secrets that have been registered in your VCS. Now, after that, the next place that I'm probably going to attack are your logs, because there's a fair amount of spillage that happens with credentialing in logs. We've seen breaches that have occurred where credentials have been spilt to the logs, and then 5 years later, somebody comes back, gets access to those credentials, tries the credentials, up they're in. But how is this any different than accessing your logs? So now my next target, knowing that 50% of all companies run Kubernetes, is going to be your Kubernetes cluster. And I'm going to attempt to get that secret because there's a pretty good chance that that secret is static. Now, I'm going to take this one step further and say that dynamic secrets are probably not enough. You're probably going to want to take this into zero trust. So as we heard earlier, if we distill down zero trust, it basically comes down to trust nothing, authenticate and authorize everything, and assume breach. Now, we just heard Armand's keynote, so this should look relatively familiar to you. And if I'm looking at implementing this into a company or an enterprise, when I see these things, I'm essentially going to distill it down to, I need to be able to take identity-driven controls, have them mutually authenticated, use the principle of least privilege to authorize, and then I want to make sure that those credentials are time-bound and usage-bound. And all of my data is going to be encrypted, whether that's at rest or in transit. Now, I want to do this in a way where I can declare my intentions, spin them up as infrastructure as code, and make sure that I have adequate observability on the side. Now, I think I have about 10 minutes left, so there's no way we can unpack all of that. But what I do want you to leave here with is an idea of how to get this started in your own infrastructures, and how do you incorporate then the dynamic secrets on top of that. So we're going to make it really simple. We're talking about containers. We're going to say we have a pretty basic application, service A and service B. We're going to say also that they're running on Kubernetes. Now, I have to make a huge disclaimer at this point in time. I in no way advocate that you should be running your databases on Kubernetes, just so we're very clear. So in order to get all of this up and running, we need to take some initial steps first. And the most important thing we need to do is lay the groundwork for these intentions, for declaring this infrastructure as code. So we're going to use some Packer for the images. We're going to use some Terraform to spin up that infrastructure as code. Now, just like everything else in our stack, they have to adhere to these principles of zero trust. They need to have an identity, and they need to be observable. And that goes for Packer as well. That means that if there's a CVE I need to be able to react to that and understand exactly where those images might lie within that golden workflow. Now, I'm going to declare my intentions for Vault. With Vault, I need to stand up the infrastructure. Equally as important, though, I need to be able to spin up those policies as code and use Terraform to create those policies as code as well. Now, Vault also, incredibly importantly, needs to have that observability. We do this via infrastructure as code because we want to drive out those human touch points. We want to make sure that there are no hands going into any of this because we as humans, we're flawed, whether that's intentionally or unintentionally. But we want to make sure that there's no point where there can be a security concern due to a human at this point. Now, I'm also going to put Consul in there. And at this point in time, I'm not ready for service mesh. I'm not ready for network infrastructure, or network automation. But I'm going to use Consul here as a form of observability so that I can see my applications, I can see how they're connected, and that also gives me a better human-readable format. Once all of this is in place, I can start to consider the deployment of my application, because this is going to be the foundation of my zero trust approach and how I can manage dynamic credentials on this. Now, in this case, it's pretty easy. I'm using Kubernetes. I can use that native JOT as my identity. So I'm going to acquire that onto my applications. And then I'm going to use that to authenticate to Vault, to use Vault as my identity broker and connect between these two different identities. I'm also going to pass through Consul so that my application is fully registered with Consul, and I can see how that's working. Now, I'm going to have service A talk to Vault, tell it I need some database credentials. Vault is going to go to service B and say, hey, I need some database credentials. Service B is going to hand back those database credentials to Vault. Vault will give them to service A, and service A can now connect to service B. Now, this works for database credentials, but it's also fundamentally the same pattern that you're going to see for something like dynamic PKI. So once you start learning one, the next step becomes much easier, which leads us eventually to something like this architecture, which means I can leverage mutual TLS via proxies and identity. Now, before, I would have had to do all of this manually, or it would have just been sitting here. The advantage is, with dynamic credentials, it doesn't matter if my container is valid for a week or for 5 minutes. It's all automated, it all rolls, and you've just drastically reduced your attack vector based off of the length of the secret and the fact that you're using zero trust. So if we look at what we just did, essentially, we required that identity-based client authentication and authorization. But we did that in a continuous fashion. Because these containers are going down, they're coming up. It happens on a regular basis. It's not enough just to authenticate once, because we can't trust anything on that network. When you're proving identity, it essentially boils down to proving who, what, and where for the user, whether that's machine or human, but also for your consuming workload and the connecting workload. And probably one of the most valuable things, which seems to be the most elementary and rudimentary, is this leveraging of principle of least privilege. If my application can only read things, then there's no risk of something getting written that shouldn't be written. So what if I told you, coming back, that companies who implemented a secure and a mature zero trust approach reduced the cost of a breach by $1.76 million? Imagine if you layered those dynamic credentials on top of that. So to bring it back a little bit, we know that containers can't keep a secret. This is a fact, and we have to assume breach based off of that. So in order to secure them a little bit more, make sure that you're implementing this zero trust, we're going to industrialize and codify. And that means everything from your infrastructure all the way through to your policies. You want to start with that piece of identity and move to secure connectivity. If you try to do everything at once, it's not going to work. There's going to be a lot of overhead involved. People are going to get frustrated, and things tend to start falling apart, at least in my experience. Authenticate everything continuously. Doing it once isn't enough. The name of the game here is dynamic, ephemeral. And that means for your infrastructure, but then it also means you need to have that for your supporting infrastructure. If you're going to blow down the entire house just to have a new color kitchen, you're going to have to get rid of the keys as well. Leverage your RBAC, your privilege, least privilege. Again, it seems elementary, it's tedious, but it's going to save you a lot of pain in the end. And then last of all, it's not a question of if you're going to get breached, it's the question of when. So make sure you have that reactivity built in, that proactivity, so that when there is a breach, you can recover as quickly as possible with the least amount of damage possible.